things looking really small.
All right, period 7. You had a pep rally, the best possible use of your educational time I can imagine. So you missed calculus class, you are watching a video. Woo-hoo! Period 3, say hi.
Hey. Hello!
All right. Good. We are going over the curve sketching problems first. Who's doing 41? What's going on?
It was like absent last class, and I sort of like screwed up.
Oh, good. Let's go to the next person in the pile, which was Elizabeth. Woo!
41.
All right, good. 44, I shall do, just because. Actually, I can do whichever one you want. Elizabeth, you pick. I can do 41 or 44, and you do the other. You want to do 41? Okay, good. No, you're not even in the camera frame or anything. I just want you to put it up. I'm going to do 44. What's up?
Oh, that was part of this.
Yeah. 44 is 124x cubed minus ln x. Okay, let's begin. Good. We're gonna go over all those too. All right. So fx equals 124x cubed minus ln x. This is exactly the kind of problem without calculus. There's no way I can do this. But with calculus, I have all the information I need. First of all, I think it's worth noting that you can only take the natural log of something positive. So just straight away, the domain of my function is from 0 to infinity. Let's just at this point jump right in and look at the derivatives. Okay, so I take the derivative. Derivative of 1/24 x cubed is 1/8 x squared minus 1 over x. Yeah? Yeah. Okay, and now I shall factor this right now. And I guess what I want to do is take out the lowest power of x, which is x to the negative 1, and I'm also going to take out a 1/8. So if I take out 1/8 x to the negative 1, then I'm left with x cubed minus 8. Again, you should always multiply it back through to make sure that you didn't make some kind of factoring error, but I have not. All right, so the derivative can be, in the most algebraically friendly way to write this, is just as x cubed minus 8 over 8x. And you could just leave it like that, knowing that x cubed minus 8 is going to change sign at 2. I would probably just leave it like that. All right, now let's take the second derivative. But of course, when I take the second derivative, I'm going to go back to the most calculus friendly form of the first derivative, which is this one. So differentiating this gives me 1/4 x, and then minus x to the negative 1 would be x to the negative 2. Okay, and again I want to factor this nicely. So if I take out 1/4 x to the negative 2, 1/4 x to the negative 2, then I'm left with x cubed plus 4. Let's see if I did that right.
How did you do the second factoring? How do you do the second differentiation?
This one?
Yeah.
I used this form, because this is the form that's most easy to differentiate. Let's make sure I did it right. I believe I did. If I differentiate this, I get, right, bring down the 2, 1/4 x, and then minus x to the negative 1 would be bring down the negative 1, x to the negative 2. Cool? Cool. All right, so there's multiple skills going on here. 1, being able to differentiate correctly. 2, being able to factor and put it in nice forms, and then you have to also make the sign charts. All right, so the most helpful form to have the second derivative in for sign chart making is x cubed plus 4 over 4x squared. All right, now when it comes to making the sign charts, let's talk about this. So what is f prime? Oh, the other thing is, well, okay, I'll do f prime first, and then I'll have some comments. So f prime, when does f prime change sign? Well, it changes sign at 2, from negative to positive, and it changes sign at 0. Now, you might be objecting, hey, you already told me that the domain is only positive numbers. But like when it comes to making the sign charts, it's often convenient to just make the sign chart for all the real numbers, and then just like ignore the ones that are outside the domain. So that's how I'm going to do it also. I have to be experienced enough to look at this rational function and know it's going to change sign at 0, and it's going to change over here. It's going to change sign at 0 and also at 2. And how does it change? Well, it's going to be basically like quadratic-y effectively, right? This function only has one root at 2, that's it. And this, so plus, minus, plus. Good. And how about so that means that my function is increasing, and then decreasing, and then increasing. The second derivative, when does it change sign? Well, there's no sign change at 0, because it's being squared. And there is a sign change, I know. There is a sign change in the numerator, but when does that sign change happen?
Cube root of 4. Cube root of negative 4.
Yeah, cube root of negative 4, which is negative cube root 4.
Oh.
So it's okay if you want to put that on your sign chart, you can. And what will it change from? From negative to positive. But all that really matters is green. I wish I had told you not to use green.
I'm sorry.
It's basically invisible on camera. Also in the classroom. Have I said this like 10 times? Like never to use green and never to use red? Green is even worse than red. I mean, I guess your handwriting's pretty good. Can you guys see that?
Yeah.
Oh,
like
yeah,
decent.
I can't see.
On video, they're not going to be able to see anything. Whatever. Here's 7. That's their fault for
That's their fault.
yeah, I just didn't know this is a no editing operation. Good. So wait, I was about to say something. The point is that only when x is positive do we care about this function. So I'm going to draw a line here and ignore everything to the left. Follow? So now when it comes to making my f number line, there's really only a single point to care about, which is 2. And what happens at 2? This function is concave up everywhere on its domain. And so what does it look like? It's decreasing concave up, and then it's increasing concave up. So what does a generic decreasing concave up function look like? Concave up, ends in the air, looks like this. And a increasing concave up function. Right. It also occurs to me that because this function's kind of crazy near 0, because natural log is crazy near 0, we should take a limit to see what's going on. So what is the limit as x approaches 0 plus of x cubed over 24 minus ln x? Wait, Elizabeth, can you switch to a different color now? See, can you get her that purple?
Just use purple from now on.
Please. Great. Okay, what is this limit? As x approaches 0 plus, this is basically going to 0. What is natural log doing as x approaches 0 plus? It's going to negative infinity. So if I'm subtracting something which is going to negative infinity, answer?
This is nonsensical.
Alright, so that's really worth knowing as well. Alright, now I think I'm ready to make the graph. And if it turns out that I don't know something, then maybe I need to go back and try again. But I think I'm ready. What's up? Yeah, okay, so Fu Cheng says, where are the roots, man? And this, I think some people have been sort of stymied by this in the past. The thing is, you just can't do that. Sorry. So when is this function 0? I don't know. Because I just straight up can't solve the equation x cubed equals 24 ln x. So this just, or at least there is no way to do it without a calculator exactly. You can kind of get some estimates and stuff, but that's the best you can do. Cool? Yeah, you can do some, which we're going to learn. Yep. Yeah, so there are
Got it.
So the question mark represents not that the sum total of human civilization has no methods, but we have no methods currently to solve equations of physics explicitly. What's up? Good. All right, but good. Now it's time to I guess we should get some y values the best we can. The only one we seem to care about is 2. So what is f of 2, at least approximately? If you plug in 2 here, you get 8, so that's like a third, minus, okay, I happen to know just like ln2 by heart, it's like 0.7. That's like kind of a thing. So this f of 2 is going to be negative, just barely. It's going to be about negative a third or so. Okay. But what we really care about is like the overall shape, not like having it be exactly accurate. So all right, let's go over here. We plot when x is 2. I'm going to have a relative minimum right here. That point is 2 comma 1/3 minus ln2, which I estimated, or you could use a calculator, I guess, is about negative a third. What else is going on? As x approaches 0 from the right, this is like positive infinity, and it's going to be so actually by the time you get down to it, this graph's kind of boring, right?
Yeah.
It just does like there's a root somewhere, and then it goes back up again, something like that. That's it. Concave up everywhere. What's that? Well, you just can't, at least not by hand. Yeah. So you don't have to because you can't. All right. Questions on this? Woo woo! Let's Karen turn the camera over here. Period 3. Good luck. This is in green. So good luck. Well, this I am talking to period 7. Yeah. Good. So this is a logistic curve. You might recall last year, Giles taught you this, and you kind of half sketched problems like this using some combination of just intuition and guess and check and hope for the best. Now that we know calculus, we know everything. So what must we do? There's actually a lot of things going on here where she says, okay, let's take the limit as t goes to infinity first of all. And what happens as t goes to infinity? What is e to the negative infinity? It's basically pretty much 0, right? So if e to the negative infinity is pretty much 0, then 4 times that is pretty much 0, plus 1 is just pretty much 1, so 10 over 1 is basically 10. So I agree with her statement that the limit as t goes to infinity is 10. What happens as t goes to negative infinity? Well, as t goes to negative infinity, then that's e to the negative infinity, so that's e to the infinity. So that's huge. So that denominator grows very, very big. The numerator is 10. So this is indeed going to 0. So I agree. So I have n behavior now in both directions. That's pretty important. Also, we can observe that as e to the anything is positive, 4e to the negative t will always be positive, so plus 1 will always be positive, everything's positive. And so the output of this function will be positive, so I agree that she says her range is from 0 to, and it's also never going to be bigger than 10, because the denominator is always going to be a little bit more than 1, as this is always positive. If I add something positive to 1, that's always going to be a little bit more than 1, and 10 divided by something more than 1 is going to be less than 10. There's actually a lot going on in this problem. Everyone cool so far? Alright, so I agree with her observation that the range is 0 to 10. And also the limits sort of support that. The domain is all real numbers, because I can raise anything. I can raise e to any power whatsoever, no problem there. The asymptotes follow from the end behavior. And of course you can also just plug in 0 and get 2, so the y-intercept is also nice. There's no x-intercept because of our conversation we just had that it's always positive. Alright, all of that is like pre-calc, sort of, if you include limits as kind of a common sense part of pre-calc. Now we get the calculus involved, and I think she skipped all the steps because you just didn't feel like putting all your work on the board. Alright, good. So Elizabeth just says, dude, I'm gonna just do this, or she's just very efficient. I guess it's not too bad. She takes the derivative, and you get, yeah.
You do the reciprocal rule.
Isn't it?
Yeah, that's what I would do too, or just put the whole thing to the -1. You guys want me to do this out, or no?
You know,
I think I said
positive.
reciprocal rule first.
Can you at least figure out how to do the point of inflection?
Yeah, can you, Karen, can you either zoom out slightly or something so I'm in frame? So yeah, so if the function, probably what I would do here is I would just put it all to the -1, that seems easier to me. So this is like 10, 1 plus 4e to the -t to the -1, and then just differentiate from there. You doing the quotient rule is kind of silly. She did the reciprocal rule, which is also like pretty much the same thing. So if you differentiate this, what do you get? You get -10, 1 plus 4e to the -t. Back inside for the derivative, to the -2. Back inside for the derivative of 1 plus 4e to the -t, which is, that's 0. The derivative of 4e to the -t is 4e to the -t back inside -1. So that's -4e to the -t. Is this in frame?
Oh, yeah.
Good. Woo! So, what is G prime? Well, we're going to get exactly what she,
Put it
No,
negative
it's
one.
negative. There's positive.
I think.
maybe she messed up?
I think she
No.
forgot the chain rules and negative.
I did or she did?
She did.
Oh, that's interesting.
I mean, you just missed it.
Okay.
You're supposed to do it on negative.
What's up? Hold on, let me just double check my work. This is 10 zoom to the -1, so that's -10 zoom 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 to the -2 back inside for the derivative of this. Yeah, I think I'm right.
Yeah.
Yeah, you have.
Yeah, and now the -4 and these two negatives cancel, and so we get. Why is everyone talking? So we get 40 over e to the t times 1 plus 4e to the -t squared. That's what she has too? No, you have a negative. Yeah. Okay, so immediately I observe something about this derivative. What do you observe? Always positive and never 0. It is always positive. And here I'm squaring something, positive, positive, positive. So this function is always increasing. Okay, now I have to take the second derivative. So in preparation for that, maybe what I should do is rewrite this derivative a little bit differently. I'm just gonna I find it easier to just use the product rule, so I'm just gonna write this as 40e to the -t times 1 plus 4e to the -t to the -2, and I'm gonna just differentiate that using the product rule. So it's not too bad, you just have to do it and not mess up. There's a bunch of chain rules going on. So what is the second derivative? It's the derivative of the first, so 40e to the -t back inside -1 times the second, so that's 1 plus 4e to the -t to the -2, plus the first, so that's 40e to the -t times the derivative of the second. And the derivative of the second is -2, 1 plus 4e to the -t to the -3, back inside for the derivative of 4e to the -t, which is -4e to the -t, because of the chain rule.
Excuse me,
Yo.
where did the -1 right after the first 40e to the -t come from?
General for the
The derivative of 40e to the -t is
Okay.
40e to the -t back inside for the derivative of -t, which is -1.
Okay.
So yeah, you do, yeah, okay, good. Now I'm gonna just rewrite this once as -40e to the -t, 1 plus 4e to the -t to the -2. I guess it's kind of hard. And now I have a negative and another negative which cancel, and so I have like 8 times 40, so plus 8 times 40, e to the, it's like I have a 2, I have an e to the -t, and I have another e to the -t, and I have a 1 plus 4e to the -t to the -3. It's pretty hard. A 40, an 8, negatives cancel, good. Right, and now I'm ready to factor this disgusting mess. You just left all this work out, right? You were just like, I don't feel like putting this on the board. Good. Not good, I mean. So let's factor out a negative 40 e to the negative t times, or no, I guess I should, kind of almost doesn't matter how you do this at this point. Maybe I want to factor out e to the negative 2t. Yeah. That would be the, according to protocol, way to do this. Factor out e to the negative 2t and 1 plus 4e to the negative t to the negative 3. If I do this, what am I left with? Alright, I grabbed the negative 40. I grabbed one of the e to the t's, so I have 1 e to the t left. And I grabbed 3 of these, so now I have 1 positive one left. And then over here I'm left with minus 8. That's it. I think. Well, I'm about to check. Minus 8, 40, e to the negative 2t. Yup. Yeah. Okay, and I'm just double checking that's all right, but I think it's right. No one's helping me, so I guess I'll assume I did this correctly. So, what does this turn out to be? Negative 40. If I distribute this e to the t through, I get e to the t plus 4 minus 8 over, the 8 came from, I had 8 times 40 here. I just left it as 8 times 40 because I knew I was about to factor out a 40. Over 1 plus 4 e to the negative t cubed. Alright, so,
Excuse me.
what's up?
Oh, never mind. Yeah, it
Good.
is plus 4 minus 8.
E to the t minus 4. Alright, so after all that work, wait, this is like not working. You guys are really annoying me. Okay, good. I did. That's down here. Okay, so this is all about doing calculus properly, not messing up the chain rule, factoring correctly, simplifying, but I now have a beautiful expression for the second derivative. And almost all of it is like irrelevant because this is always positive because e to the negative t is always positive. So something positive cubed is always positive, so it can be ignored. E to the 2t is also always positive because e to the anything is positive. So this entire denominator is positive. So the only thing I need to look at is this numerator. And what's going on with this numerator? Do we get a sign change? We do. We get a sign change at ln4. Yeah, at ln4, this guy changes from negative to positive. And since there's a leading coefficient negative, that is how, you didn't even do the sign charts. Okay. Coming back over here, what have we learned about f prime? We've learned that, Cameron, shut up, good. We've learned that the derivative of, this is g, is negative. Is that what we said? No, positive, right? Always positive. And g double prime, we have now seen changes sign at ln4. And it changes sign at ln4 from positive to negative. And so there is, what we have is a function which is always increasing, but is first increasing concave up, and then is increasing concave down. And so what we end up with is exactly the logistic curve that you remember from pre-calc B, but now we've actually proven using calculus that it really does what we say it does, right? That there is this point of inflection. I think this is the what you guys were telling me. Giles actually uses the word point of inflection, right?
Yeah.
This is the one time in your math life that you've heard this word before, and there is a point of inflection at x equals ln4. And that's the point where the function is increasing fastest. So this is when you put two bears in the park and there's like a lot of picnic baskets and it goes faster, 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 faster. And there's so many. Have we had this conversation? No. You put a boy bear and a girl bear in a park with like a lot of picnic baskets. What are they going to start to do? Eat. And you guys are missing the point of the story. They're going to make bear babies, and then there's going to be more bears, more bears, more bears, more bears, and the bears will grow exponentially because there's so much food. But this park doesn't have an infinite number of picnic baskets. It has enough picnic baskets to support 10 bears. And so what will happen is, at first, the number of bears will grow exponentially, but then at a certain point, things start to get a little bit crowded, and there aren't so many picnic baskets. So then it will slow down, and we'll eventually end up with a park full of 10 bears. Good. All right, I'm not sure that was worth going into all the details. Very fast now. Turning to number 19. This is a more kind of traditional function, which is still pretty hard. X, 4 minus x to the 1/2. What does Caroline do? She takes the derivative. She takes the derivative again. Lots of factoring happens. Oh, Caroline. Okay, this is right, but like I want to kind of push some good habits here, which is like this is like the opposite of good habits, because it just makes it way harder on you. Like first of all, you should label your number lines. Which is your number line? This is F prime? Yeah. Okay, so, and it's also true that, I think you did everything right, by the way. I'm just trying to get everyone in the class to like, be a good student. No, because this looks very familiar. And so, is this what you guys got also, that there's a sign change at 8/3?
Yeah.
Good. This denominator is always positive, and there's a sign change at 8/3, and that sign change, I think it's maybe more helpful to write the derivative as like -3x minus 8/3 over root 2 root x minus 4, because that just makes it easier on your brain that you see that this is just a line with a leading coefficient negative, and so the line is upside down, and so it's going from positive to negative, which tells me my function is increasing and then decreasing. Whereas f double prime, I will also assume you did all your calculus correctly. Is that right? Is that the same second derivative that you guys got? Fu Cheng says yes.
Yeah.
So if you do your calculus and your factoring correctly, that is your second derivative. So it's again maybe helpful to factor out a 9. So it's like 9 x minus 32 nines over 4 root 4 minus x. And so the second derivative. So do we get a point of inflection? Wait, I'm kind of confused now.
No, we don't.
No.
Because like always be getting
So
32 nines is less than 3.
Jacob, that's your maximum. And then you'll be getting smaller. And that's the
Yeah, you did. Way to doing it.
Wait, this is taking too long. Rob, can you read the board? So wait, Caroline, I think you like messed up your algebra. Can you like find your mistakes with like take a helper with you
Right.
to the board? We're gonna come back to this in a
No,
second.
that's wrong. Like it should be going down. The first line should be going down because like the limit is -2.
Okay, you use red. I can't follow your work. This was a relatively easy one, I think, right?
And it should
Oh
go.
God, Jacob, I can't follow this at all.
Yeah. Okay.
So this is 3x to the 2/3 minus 2x. So you first differentiated, and you got 2x minus, sorry, 2x to the negative 1/3 minus 2, and then you factor out a 2x to the negative 1/3, and you're left with 1 minus x to the 1/3. Let me just double check that that's right. It is. So then this is really like -2 cube root x minus 1 over cube root x. So this, I think, is the most helpful form to have the derivative in. And that tells you that the sign chart, so that's why I think you have a problem here, right? Because it's also changing sign at 0.
Yeah. Wait, I put that. I had it changed. I signed it.
Okay, and then you have to take the second derivative. I'll just kind of go up here. The second derivative of this is -2/3. Why are you talking? It's really, really annoying. I'm trying to talk, and I can't even talk because you're talking. Why are you doing that? Thank you. All right, so if I take the derivative again, that's -2/3 x to the -4/3. And so what is this second derivative? It's -2 over 3x to the 4/3. All right, so in this case, the calculus and algebra were very easy and short, but you still had to have some skills to factor it correctly, and now you have to make the sign chart correctly. So what does the sign chart look like for f prime and for f double prime?
You dropped an X.
That's possible. So wait, hold on, let me double check this. I'm trying to do math while people are chattering in the background. It's like very distracting. So here was my original function, 3x to the 2/3 minus 2x. If I differentiate, I get 2x to the -1/3 minus 2. That's correct. I factor out a 2x to the -1/3, so that's correct. And if I distribute it through, I also get -2. So I factored correctly. And
It's F double just did right.
And now up here, oh, I just didn't write like the symbol x, otherwise it was fine. Good. Okay, so what is f prime? You have to be smart enough to look at this and see, even though this is not a polynomial, you use your polynomial skills. The bottom is cube root. I know everything there is to know about the cube root function. It changes sign from negative to positive at 0, and this is going to change sign from negative to positive at 1. So putting this all together, I have something changing sign at 0, I have something changing sign at 1, and I have a leading coefficient negative. So this might as well be just a quadratic, right? Which changes sign at 0 and 1, but has a leading coefficient negative. So the sign chart is like this, and we have 0, 1, negative, positive, negative. All right, that's kind of hard, but that's what you have to be able to do to get this all right. You have to be able to make these sign charts correctly. And f double prime, you also have to be aware that if you raise something to the 4/3 power, it's always positive. Because the 4 is even and it will kill any possible negative. So since this denominator is always positive, this is just negative always. And therefore this function's decreasing, increasing, decreasing, and always concave down. So when you put it all together, you get a decreasing concave down function from negative infinity